Today you guys are going to learn how to, or review how to, solve systems by using graphs and tables, and then later you'll learn how to solve systems using substitution and linear combination. The first part today will be by solving by graphing, and this is in section 3-1. Whenever you solve by graphing, you're going to see where they meet. A better word for that might be where they intersect. In problem 1, we have two equations. Two equations is what we call a system of linear equations. I will teach you how to solve by graphing in part 1 and by how to use a table in part 2. In order to solve by graphing, you want to make each equation equal to y. In the first equation, you're going to take over the 3x. Then you'll divide everything by 2. You have y equals 3 over 2x plus 4. That's the first equation. Go to the graph and plot some points. Start by going up 4. Then use your slope to rise and run, up 3, right 2. Give yourself some points on the right and the left. So go back to your original and go down 3, left 2. Do that until you have a pretty good picture. Make sure to put arrows on your lines. The second equation, you also have to solve for y. So we're going to take the x over. So you will get 2y equals negative x minus 8. Next, you'll divide by 2. Remember that the negative sign in front of the x is actually a negative 1. So you get negative 1 over 2x minus 4. Go back to your graph, plot the y-intercept down at negative 4. Then go down 1, right 2, down 1, right 2. Notice how your points that you're plotting are going away from the other line. So on the other hand, go up 1, left 2, up 1, left 2. You can see how the lines meet perfectly at a point. The point that they meet at is the solution to both equations. In this case, the solution point is negative 1, 2, 3, 4, and negative 1, 2. If you wanted to check if you did this right, take negative 4 and negative 2 and plug them into their corresponding x and y values in both equations. In the top equation, when you plug in negative 4 for x and negative 2 in for y, when you add them together, you'll get a positive 8. In the bottom equation, when you add them together, you'll get a negative 8. That goes to show that that is the point that solves both of the solutions. The next example I'm going to teach you how to do using a table. In the Got It problem, I'll teach you how to solve the system using tables. I personally prefer to use tables after they're both set equal to y. In the first equation, if you set it equal to y, you pull over the x and you get negative 2y equals a negative x plus 4. Divide by negative 2. Y is a positive 1 over 2x minus 2. Do this again for the second problem. Take over the 3x, so you get y equals negative 3x plus 5. And that's solved for y. In the first example, we would have graphed both of them and see where they meet. In this problem, I teach you how to solve using a table. Graphing is much easier. Just like you usually would, you're going to make an equation, your next y table. Okay. The first column will be for your first equation. The second column will be for your second equation. You can pick values that you usually pick, but sometimes they're not going to work and you have to pick further points. I'm going to pick the ones that I normally do. I'm going to see if they work, and if they don't, you need to pick more points until you get them to work. If I plug negative 2 into 1/2 x minus 2, I get negative 1 minus 2, which is negative 3. If I plug in negative 1 into 1/2 x minus 2, I'm going to get an ugly fraction, so I'm going to wait on that. If I plug in 0, I'll get 0 minus 2, which is negative 2. And I'm going to skip positive 1 because I'll get an ugly fraction. I'm going to plug in positive 2. If I plug in positive 2, I get a positive 1 minus 2, which is negative 1. I'm going to plot those. Actually, you don't even need to plot the points. Let's move on and just plug into the second equation. Plugging in negative 2, I'll get negative 3 times negative 2, which is positive 6, plus 5, which is 11. I can plug in negative 1, but I'm just going to try these and see if they match. Plugging in 0 will give me 0 plus 5, which is 5. Now I'll try plugging in a positive 2. Negative 3 times 2 is negative 6, plus 5 is negative 1. Notice at this step, we get the same results. Therefore, the ordered pair that satisfies the system of equations is the x value of 2 and the y value of negative 1. You don't need to graph them, but if you did, you would see that they meet right here at 2, negative 1. If you choose to use a table and get an answer, you do not need to do the graph. The next part of the lesson has a concept summary of all the different solutions of linear systems. You need to become familiar with these terms because you will be tested on them. If two lines meet in one spot, that is one solution. The solution is the x, y value that they meet at. That's called consistent, and it's also called independent. If you graph two lines and they're the exact same line, the answer is infinitely many solutions. You can write it with a sideways cursive 8 and write solutions. That stands for infinite solutions. This is called consistent, and it's also called dependent. The next type of graph you might have is when you have parallel lines when you graph them. These will have no solution because they don't meet, and they will be inconsistent because there's no answer. In the first one, you should notice that the slopes, abbreviated as m, are different. An example B, something like y equals 3x, and something like y equals negative 1/5 at x plus 4, as long as the slopes are different. The second one, the equations reduce to the same thing. For example, 2x plus 2y equals 40, and x plus y equals 20 would both reduce to the same equation and therefore would be the same line. The last example would be parallel lines. In these ones, the slope, abbreviated as m, are the same, but the y-intercept must be different. For example, y equals 2x plus 1 and y equals 2x plus 5. We're going to apply this on the next page. In problem 4, the title says to classify without graphing. Without graphing is it independent, dependent, or inconsistent? We'll solve each one from y and compare. The first equation, let's solve it for y. So 4y equals a positive 2x plus 6, positive 2 because we moved it over, and y equals 1/2 x plus 3/2. Notice I reduced the fractions when I divide by 4. In the second step, we will divide each by 8. So I will get y equals a positive 1/2 x minus 12 over 8 is 3 over 2. Notice that while these have the same slope and almost the same y-intercept, one y-intercept is positive and one y-intercept is negative. So I have the same slope, I have different y-intercept. Therefore, the problem is, if we look back at our sheet, they would be parallel lines, so they have no solution, they are inconsistent. So to answer the question, we can say they are inconsistent with no solution. In the got it problem, we'll solve for y one more time. In the first one, y equals 3x plus 4. And the second one, negative 1/3 y equals negative x plus 1. We must multiply this entire thing by negative 3. So we get positive y equals positive 3x minus 3. I got that by multiplying by negative 3 to clear my fractions and the negative sign. These again have the same slope, different y-intercept, so this would be inconsistent, and there would be no solutions.